Hi everyone.
Hello, welcome back.
Yes,
Uh,
welcome. Actually,
Today,
today we have different different issues. Like always, we have something nice, different. My computer just stopped to work, so I'm using my phone and I'm gonna be here helping Anna
yes.
somehow. But
So we are sorry
welcome
if you
back.
will have like a robotic voice sometimes. I will try to.
Sometimes. So, we are having fun doing this workshop, and we hope you guys also enjoy as much as we are enjoying. And I'm
Mhm.
Felipe Matias, and this wonderful lady here work with me is Ana Rita Mahano. And we are
Yes.
organizing this workshop series called Hands On at PhenomeForce Group, right? And if you are new here, in our YouTube channel, we already have some workshops, I guess, 8 workshops. So go
Mhm.
there and see what the work that we have been doing. And also sign up right here in some point. Sign up for our, keep following our activities. And don't forget to give our like, because it helps us to send this information for more people, right?
Yes. Yeah. So I will start as usual introducing who we are. So that's this part can be boring for the people that have been following us all these Fridays. But for the new ones, we want to show who we are. So we are PhenomeForce, and we have already a lot of people following us. So we are very happy because we are building this community of beginners and experts in plant phenomics. So we started this project last February at Phenome 2020, and we want to keep going with these, like providing support and resources to people that works in plant phenomics. So if you want to know more about us, we have a website, but also we are on Twitter, so you can follow us there where we share information, events, and what we are doing. And also we have a Slack workplace, which is a hub where people can connect and ask questions. So if you want to be part of this Slack workplace, just send an email to phenomeforce@gmail.com. um, so for people that are not very familiar with Slack, so this is the kind of screenshot that you will have. We have different channels. You can decide to join any of them based on your interest and ask questions. For example, today, girl asked, she's going to start working with hyperspectral data. So she can join the hyperspectral channel and ask like people in the community that works with hyperspectral data what she has to do and where to start from. So when you join the Slack, we ask you to introduce yourself in the introduction channel, so people will know who you are and they can also contact you if they are interested in collaborating with you. We also ask you to give us feedback on this workshop series in the Fridays and so on channel, but also in the suggestion channel. So me and Felipe, we are already thinking about what we are going to do next. We think that will be useful to have more workshop because it's the one that get people engage and also make them to learn. But of course, if you have any suggestion or any tool that you want to present or anything that you want to share, please contact us. We have also the job offer channel and the event channel. So in the event channel, the first event that we are promoting is the 2021 MPPN annual conference that will be online on February 16 to 19. So we strongly recommend you to register to this conference because as me and Felipe, many people will be there working on plant phenomics, and so you can contact and connect with people and start new collaboration or like ask anything that can help you with your project. So here you have the date and the deadlines. So, but of course, if you are already part of the Slack workplace, you can find the same information in the channel events. And so, uh, talking about what we do, we started this series of workshop, which is called Fridays Hands-On Workshop Series. We are already at the 9th workshop, and next week we will be our last for 2020 probably. We don't know yet, but so why we did that? So we did this because we think that one of the most challenging part in plant phenomics is dealing with the data, how to manage them and how to analyze them. So Philippe just abandoned me. But anyhow, so we decided to invite speakers that they have to promote open source resources in plant phenomics. And so welcome back, Philippe.
Thank you.
And so this is why we had this Fridays on Workshop series. This workshop series was promoted from the MPPN, but also it got the support from the Midwest Big Data Hub. We want to thank Jennifer Clark and Christophe, but also Noah Falgren, which is the guy that helped us with all the technical and computational issue. And so, speaking of workshop, today we have an amazing workshop, and Felipe is going to introduce the speakers, right?
Yes, I'm gonna try, Anna. As you see, my internet today is not helping that much. But guys, as Anna was saying, it's super important to be part of this conference and go there. For example, Anna and I, we met in a conference organized by any APPN, and we are organizing also this workshop today. So it's important, really important. And this year is interesting because it's going to be online, so you can follow from where you are, and what is a really great point for the next conference. Well, this workshop you had is going to be a little bit different. We didn't made a binder environment, but you can follow the steps in this web page. So if you sign up to be part of this workshop, you receive an email saying with the link, which is this one that you're seeing right now. But the speaker is going to show how starting the application. And you're going to see, you can continue, Anna.
Yes.
And you, if everything goes well, you're supposed to see this interface from where we're going to have our workshop today with the software ImageBreed. And with this, I'd like to introduce our two speakers today. We are really, really happy to have you two guys here with us and sharing your knowledge. You are doing a really great job in phenomics, and we are super happy for you guys accept being here. So today we have Kelly Robbins and Nicolas Morales presenting their workshop, which is the name is Getting Started with ImageBreed, Managing and Storing Drone Imagery. So thank you guys and welcome.
I will add them on the screen. So welcome guys.
Hello.
Workshop series. So there will be first a brief introduction from Kelly about ImageBreed, and then Nick will lead the workshop, the practical part. So as usual, if you have any question, you can write them live on YouTube, and we will ask the speakers to answer. So I think they prefer to be stopped, but of course it depends how the workshop is going, and so of course we will give them time to finish their analysis also.
And by the way, as we always say, we are using internet devices today. I'm being the example. So if we lost connection, please stay there. We're going to do our best to come back in time and finish our workshop. And also, if we also can schedule a new time to have a good time here and present again. All right?
Yeah.
So having fun. And let me know if you guys need anything.
Yeah, so and with this, I think we will leave Kelly or Kelly Nick to speak. Yes, and we will leave. So good luck and enjoy your workshop.
Great, thanks for that introduction, and thanks again for organizing this great workshop series and for having us here today. So I just wanted to start by giving a little bit of a background to ImageBreed in terms of where it came from, what we work on, in the Robbins lab at Cornell before I turn it over to Nick to do the actual demo. So in our lab, our focus is on developing approaches to modeling data that come from new technologies, but also taking it, a step further and really figuring out how we can integrate these new technologies into breeding programs with the ultimate goal of, increasing the efficiency of these breeding programs. One specific area of focus in our lab has been using, proximal sensing technologies to try and develop high throughput phenotyping methodologies for modeling growth and development of various crop species. So we work across, several crop species. Really, the idea is to try and understand the genetics of growth and development, how we can potentially breed for different growth and development profiles in different environments, and how growth and development affects observed G by E interactions or genotype by environment interactions that we see in the terminal traits. When we started working in this area, we were collaborating with the Michael Gore lab at Cornell. We inherited some scripts that were developed in his lab by Nick Kazmar, Dana Lute, and some others, which was a great tool for us to be able to process these images. But in the big picture, what we want to do is integrate these technologies into breeding programs, and to do that, we have to be able to combine what comes out of these pipelines and these image processing pipelines with all the other types of data that we need to have to effectively run a breeding program. And so that's where Nick Morales came in. He's a third-year PhD student. He is in the Robbins lab, my lab, but he's also in Lucas Mueller's lab. And Lucas Mueller at the Boyce Thompson Institute developed really a fantastic breeding data management system called BreedBase. And shortly after Nick joined the lab and started working in this space, he came up with this great idea, which was to start to integrate these pipelines into the BreedBase system to make this really accessible to breeders for making decisions that were impactful in their breeding programs. And so really just started from an idea that Nick had. It's grown from there. I'd just like to say a special thanks to Nick Sant'Antonio, who really helped us work through and apply this and provide a lot of valuable feedback, and Sam Bovain, who's a developer in our lab that's also started to work on this as well. So prior to Nick joining the lab, he had a lot of experience working with Lucas Mueller on BreedBase, which obviously has helped us pretty rapidly develop and roll out this solution. And with that, I will turn it over to Nick to run us through this demo. He really is the expert, so that's all I can contribute to this workshop. So take it away, Nick.
Thanks, Kelly. And thanks again for Felipe and Anarita for hosting this workshop, and for everyone joining.
Okay. Nick, if you want to share your screen, I can put it on the...
Okay.
Okay, I will leave you alone on the screen. Yeah.
Can you see the slide?
Yeah, so, okay, perfect. You can go.
Okay. I just have a couple slides before getting into the hands-on. So, like Kelly said, the solution that we've come up with and that I'll show here, it builds on BreedBase, and BreedBase is 100% open source, and it's been in development in Lucas Mueller's lab for many years. And I was working in Lucas's lab prior to starting the PhD with Kelly and Lucas. And the system can be deployed using Docker. And Docker is a great way to package and distribute software, but especially for web services. So just to give an example, I mean, so the system runs in your browser, like Google Chrome or Safari, and often the first thing you want to do in your breeding program is to get your germplasm organized. And so here's there's a search for searching germplasm, and so you see some maize hybrids here, and also some barley accessions. And so these germplasm are what the field experiments are made out of, and they're pretty foundational. And you can add a lot of metadata to those entries, such as pedigrees between them. So in the breed base, you can manage different locations through the web browser. So these are locations where your field experiments are planted. I'll show this in the demo. And so there's tools for managing your field trials. And here the green leaves are a number of different field experiments. And they can be organized in folders. And in these, the blue briefcases are the breeding programs. So we have just organizational tools for kind of managing your field trials. And what the field trial ultimately is in the database is it can be represented in this picture where you have different plots. So each of these squares is a plot, and you have some accession planted there. In this case, this hybrid was planted here. And these plots are arranged in rows and columns, and you can have different block numbers. This picture represents the block numbers in the different colors. And so the database has this as the field trial. We'll see that in the demo a little bit. So we can also upload genotypic information into the database. It can be high density. For instance, this is an example, almost 1 million markers of this genotyping protocol. It's kind of slow at the moment, but it's in development, but it is a solution. And of course, what I'm going to show here is the tools for managing different imaging events on your field trials. So, for instance, like these are different field trials, and within these, there's multiple imaging events, and we'll see this in the demo. And I wanted to mention that a big effort is to try to develop a way to share data between services, and the breeding API is something that's been being worked on to, for instance, read or write data from a database. So it could be breed base. So you have some persistent web database here, and you could read and write data into your R environment or into a field book, like a mobile application, or to any other plant reading service that has also adopted the breeding API. So this is a big effort and still needs a lot of work, but it's an important goal, I think. So now I'm going to just transition to the the web page that Felipe mentioned. From this page, it tells you how to deploy, how to launch your own instance of ImageBreed. So the prerequisites are you need Docker and Docker Compose installed on a machine with at least 8 gigs of RAM and 50 gigs of disk. So those are the only requirements you need. And this page has a lot of information. However, for this demo, the only thing you need to know is this first part here. So you need to have a copy of the provided Docker Compose file, and then you execute this command. So the Docker Compose is this file here, and it's a configuration file, but the way this works is you give it an image name, and when you yeah.
Hi, Nick. Sorry to interrupt. Can you increase a bit the font so
Sure.
yeah, so people can follow better? Let's see how it looks. A bit bigger, maybe.
Okay.
Okay, that's perfect. Thank you. Sorry.
No problem. Okay. Yeah, so this Docker Compose file, you don't need to change anything in it. You just need to copy the contents of it onto your own machine. But in principle, so what this does is it will download this image from Docker Hub, and it'll start the web service. There's a number of commented out lines here, but this is for if you're configuring the service for actual production. I won't get into this, but if you have questions, we can talk about it later. But essentially, you don't need to change anything with this file to begin. Here, should I increase the size of the font here?
Let's see. No, I think it's pretty okay. So
Okay.
Okay.
So here, thanks. Yeah. So here, I have the directory for the that I just showed. Okay, I got logged out. Let me just log this back in. So here is that directory, and I have the Docker Compose file here. And so then the only thing I have to do is type that command, Docker Compose up, -d for detached. And so then it will pull in the Docker images. That can take some time, and then it'll start the service. If you do this on your own computer, once the service is working, sorry, let me go back here. Once the service is up, you can access it from this URL. for this demo, the machine I'm using is running on the URL ImageBreed.org. So it's just a live website, but in practice it's the same thing. So I hope that's not too confusing. But since I have this configured on my machine to broadcast to ImageBreed.org, so when I start the service here, I can just directly go to ImageBreed.org. The first thing on this website is you can log in. So on the top right here, you need a username and a password. For this demo, I have a user called Jane Doe, and this user exists if you were to start your own instance as well. Okay, so I logged in. Now I had provided a few data files to start the demo. One of those files was a zip file containing orthomosaics from a MicaSense 5-band camera. So these orthomosaics are of a alfalfa experiment, and the reason we have five different orthomosaics is because this is from a 5-channel camera. These orthomosaics are from Pix4D, so we use Pix4D to assemble these orthomosaics. And so in this demo, we're assuming that you can create these orthomosaics outside of using either Pix4D or open drone map to create these beforehand. Another file here is a file describing the field experiment. This is the file that we'll upload into ImageBreed or BreedBase in order to save the field experiment. And in the first column is a plot name. So this is just a unique name for the plot. The accession name, this is either the hybrid or the variety, the inbred line, what have you, that you're planting in that plot. So these names are accessions. Then here we have plot number. So this is just a unique number that you can use to identify which plot you're in. And then we have the block number. So if you have any blocks in your field, you can indicate which block these plots are a part of. Now, these first 4 columns are these are the only required columns, but there's other information that you can provide, and kind of most important, I think, is the row and column number. So this indicates kind of the spatial position of the plot in the field. So providing the row and column number is important, but not required. So there's no questions with that. We can start loading this field experiment into the database. Now, so here we have four menus at the top. From these menus, you can access all the functionality in the database. The first thing I want to go to is manage locations. So in the this is what it has in this is the basic locations that it has, and so for instance, if I want to add a new location, I can click somewhere on the map and add location. So we have to give a few pieces of information, like a name. So we'll just call this field location 1, an abbreviation, the country, the breeding program that this location is part of, the type of location. So this is a field location this is where I want to say that field trial occurred at. So it'll automatically fill in the latitude and longitude. And this last piece of information is important. So you can search for your location on this from NOAA, and NOAA has a number of weather stations all over the country, and so you can find which weather station is closest to the location you're trying to add. So for this demo, I'll just use this weather station identifier. So this is the information you need to add a field location. So it says location added successfully, and the NOAA ID is an actual NOAA ID. So I'll click OK, and now that location will show up on the map. So so we've managed our field location. You don't have to add this every time, right? If you have a research station, you add it one time, and then you just keep using that. So now to add the field experiment, I go to Manage Field Trials, and on this page, I'll zoom in a little bit. there's these two buttons at the top. So you can upload an Excel file, upload an existing trial, or there's some functionality to like create a trial, like to do the randomization and stuff in the database. But in this case, we're just going to upload this this field experiment that we've already defined. So I go to upload existing trial. It's a workflow, so there's a number of steps. The first step is just some intro, gives you some information. I'll skip this, but go back. The second step, you can choose to either upload a single field trial, or if you have an Excel file that has many field trials in it, you can choose to do that. In this case, we're just uploading a single trial. So click go to next. So here we have to give a name to the field trial. It has to be a unique name. Let's just say field trial 2020. It's part of the breed-based breeding program. It's planted at this field, the location we added earlier. There's the trial type. It's just a label, so I'll just say it's a phenotyping trial. The idea here is just to kind of describe what kind of field trial, at what stage of the breeding cycle, if it's a preliminary yield or advanced yield.
Excuse me, Nick?
Yeah.
Can we make try something? Could you remove your headphone and try to see if we get a better song? Because there is some really nice ocean effect, waves.
Oh.
When you're talking, yeah. Just we're gonna only try if it's gonna be better,
I'm using the microphone in the laptop.
Oh, okay. I see.
I don't know. Does it sound like a kind of like a computer sound?
No. It's not like mine was.
Oh, okay.
Okay, it's not a big problem. Just to see if we can improve this ocean effect. But anyway, you're doing a great job. I'm also came to ask people, guys, please send questions here in the comments, and then Nahiti and I, we're gonna come back and talk with Nick. All right?
Okay, thanks. Yeah, I hope it doesn't sound too strange, but I don't think there's anything I can do about it.
Oh, it's okay. Yeah, it's more. I was thinking maybe if you only use the natural environment instead, the headphone could be better. But anyway, okay, keep going. Thank you.
Okay. So then you give a year. So when did this field trial occur? Or so yeah. Or when did it start? Optionally, you can give some metadata. How wide or long were the plots, or what was the size of the field? I'll just leave that blank. But you have to give a description. So the field trial I'm uploading had 5 accessions and 4 replications. The stock type being evaluated is an accession. I won't get into the details here, but you can evaluate different kinds of. Sometimes you're not evaluating accessions. But in this case, we have defined accessions, and this was say complete block or four complete blocks of 5 accessions. So now I'll select the file, the Excel file here. The Excel file, and I'll go to the next step. This next step, it's just some other metadata. Is this trial following up a previous trial? Will this trial be genotyped? Will crosses be done? It's just metadata about the trial, and then you validate the form, and then you click upload trial. Now, so in this case, the accessions in this field trial aren't in the database. So accessions are their own element in the database, and you want them to be as unique as possible, so that potentially you have many field trials using the same accessions, the same germplasm, and so what this is saying is that the accessions I had defined here, they need to be added into the database. And so if I scroll down, what I can do is I can add these missing accessions to a list. So I'll name this field trial 2020 sessions, and I'll click add to a new list. And it says added them to a list. Then I click add these accessions to the database. This blue button here. This brings up this is what you're going to see is the standard way of adding accessions into the database. You can you can upload a file. Optionally, you can upload a file to add those accessions. In this case, I'm using lists. So lists are a way to add accessions. So I select the list that I just made. This list contains those accessions. I click continue. It tells me that none of the accessions in that list already exist. So we knew that already. Then it does a fuzzy match. So because a lot of times what happens with your germplasm is you'll have like a transposition, or you'll have like an underscore where a space was, or it was uppercase when it should be lowercase. So this fuzzy search it identifies any names, any accession names in the database that look anything close to the accession you're trying to add. So in this case, on the left side are the names I'm trying to add. In the middle is, it shows that there exists an accession in the database called test_accession. So this looks a lot like the name I'm trying to add. So this is a tool to try to curate your germplasm to make sure you're not adding like duplicated names into the database. In this demo, all of the accessions I'm adding are indeed new. So I can kind of skip this curation step. I'll just say I'm continue saving the name in my list. Like, don't do any curation, and I'll continue. And this is the final step for adding the germplasm into the database. You have to give the species of the accession. So in this case, in this demo, these are intended to be alfalfa accessions. The orthomosaic we have was of alfalfa, so I'll say that. Optionally, you can you can group these accessions into populations, or you can assign them to an organization. And finally, these are actually the names I want to add. So I click Add Accessions. And so it says that they were added, and each of them has its own page. I won't click on them at the moment, but you could then go to those pages for those accessions. I click Close. Once all your sessions are in the database, so I can click here. There were no errors regarding missing seed lots, so I'll click here. And finally, I can upload the trial again, clicking here. So it's a little bit. So if this Excel sheet I had, if these accessions were in the database, that process would have ended much sooner. But in that case, I had to do the curation step for those names. So finally, the field trial was saved. So I'll refresh the page, and so then we see the field trial that is saved. I'll double click on this, and it'll open up the page for this field trial. There's the kind of the information we just entered. There's a lot of tools on this page, but I want to show. So if you open this field layout tools section by clicking, you can view that representation of the experiment. So it's saved, and you can see it. The thing I need to do before I can start doing the image stuff is I need to set the planting date. So I clicked on Edit Trial Details, and I can edit the planting date. So let me say it was planted on October 1st, and then I can click Save Changes. Okay, it was planting date was changed, so I can close and then we'll see the planting date here. So that concludes adding the field experiment into the database. So the next thing is to add these orthomosaics into the database. So I go to Manage Drone Imagery. I'm going to zoom out a little bit. So there's nothing to show yet because we haven't added anything. But I can start by first uploading the imagery. So I can click here. One thing I want to point out though is I've only been developing this. I've only been testing it against Google Chrome. So I recommend using Chrome because it may not work completely on other browsers, but yeah. So I'm using Chrome here, and if I click upload imagery, again we get a workflow, and again it starts with some information. I'll skip this for skip the intro, but it also provides some example data. Actually, if you can from here you can download the same exact example orthomosaics that I have here. But I'll go to the next step. The first step here is to select the field trial. So that's why first we have to add the field trial. So click that, select the field trial we just saved. To go to the next step. And so this third step is where we define the imaging event, or here I call it a drone run, but we fly a drone over the field, and so here we can define that imaging event. So you have to give a name for the imaging event. The example is to use the field trial name plus the date. So that's a good template to use. So the field trial name, and say the date was October 7th. There's a little bit of metadata here. So the event type. So is this high resolution or low resolution? Like, kind of the idea here is like, was this like a from a plane or was it from a drone? Like, so drone, you can get higher resolution. So it's just a label. The type of sensor you used. So there's we have the MicaSense camera or a couple color cameras. For this demo, the images were from the MicaSense 5-band camera. So next, you have to select a vehicle, and so you have to add a vehicle. You don't. There's none. So we call this the Robbins Lab M600, and this is a DJI M600 drone, and so that you can name it whatever you want, and you can list the different batteries if you have. We have like a few different battery sets for this drone, and just to keep track of like which battery you're using when you flew. It's not really that important, but you can list the names of the battery sets here, and you can click submit. So it says the vehicle was added. So I can click OK, and I can close this. So now, since I added it, it shows up. I can select it now. I could add more drones if they don't show up here. And I select the battery that this imaging event used. But again, this isn't really that important. There's a description field for the imaging event. So you can give some information about how you flew it, a flight at 25 meters, things like that. Any day, I don't know. And then this is the most important part, to give the date of the flight, and the date of the flight has to be after the planting date of the field trial. So that's just logical. So say this flight was on the 7th of October. Right? You can give an hour to, like if you're doing many flights or many imaging events per day, you can give a time. And then go to the next step. So this part is this fourth step is to give an option to upload the raw. Like currently we're only using orthomosaics, like uploading orthomosaics into the database. But ideally, you would upload like the raw images you collected, and the database or the system would would be able to stitch them for you. But currently, we don't have a very good stitching. So the recommended thing is to upload orthomosaics. So now here it's asking you, are you not uploading an orthomosaic? And so we can say, no, I am uploading a orthomosaic. So if you said yes, like the idea is you could upload the raw images, but currently we'll just upload orthomosaics. And here, number of spectral bands. So we had 5, since this is a MicaSense 5-channel camera. But you could select 1, 2, 3, 4, 5, 6, or 7. If you have, depending on how many orthomosaic images you have. So we'll say 5. And go to the next step. Here, this is the last step, and so there's these 5 separate inputs, and so we're using MicaSense camera. So first we select the blue image. So this first one here. So I'll select that blue image. So it's the first band. And we have to give a description. So I'll say this is an ortho from Pix4D. And we do the same thing for the 5 images we have. So say give it a description. This is for green. So it's the second image, second band. And then do it for the red. I'm just using the same description. They came from Pix4D. And this is for the red. So it's the third. And then the near infrared. This is the 4th band of the MicaSense camera. And finally, the red edge band. So this is the 5th band. Okay. And then I can click submit. Now, this upload, it works for pretty large images. I think the largest images I've used are about 16,000 by maybe 16,000 by 12,000 pixels. So it works for large images. Maybe not the largest, but I think 16,000 by 16,000 is a pretty big image. So now the imaging event we just added will show up in this display. So if I click this, it'll expand. So I have one imaging event, and then if I click, it can expand again. And now it shows the information that we just entered, like the date, And now I can get into the actual process of this image. So this blue button is to start the processing of that image. So I click to run the standard process. Brings me to this workflow. So the workflow starts with an introduction again. Essentially, what will happen is we'll take one of those bands, since we have 5, right? Blue, green, red, near infrared, red edge. We'll take one of them through the whole process, and then it will apply that same process to the other 4 bands, since they're the orthomosaics are perfectly superimposable. So if I rotate one of them and then apply a template onto it, I can apply that to the rest of them, and I can get plot level images in that way. So that's what this is kind of explaining. I go to the next step. So this is kind of what I just said. We'll select one of the bands to take through the process, and it's recommended to select a band that has high contrast, so like the near infrared band. And so this table will show the bands that are part of this imaging event: the blue, green, red, near infrared, and I'll select the near infrared to take through this process. So I'll click the next step. So ground control points, they're useful if you're doing repeated flights on a single field. Ground control points let you kind of automate this process. If there's time, I'll show this. First we have to define the ground control points, and if we had a second imaging event, I could use those ground control points to automate the process. So has a previous imaging event, completed the process, and has ground control points defined? No, not yet. So I'll just skip and go to the next step. So this 4th step here is to rotate the image. A lot of times your orthomosaics aren't perfectly oriented, and so on this screen, we can rotate it to correct the rotation. I can click this button to draw like a perfect template, or perfect 90-degree angles, and then you can use this bar to rotate it. I can zoom out on the web browser if I hit if I do Control-, so I can zoom out all the way, and can use this toolbar to get the rotation lined up as best as I can. So that looks fairly straight. This was alfalfa, and it was planted, wasn't planted using like a GPS tractor, so it's not perfectly straight. But with maize, actually, with maize, since they use like it's more automated when they plant it, so actually the fields are much more uniform. Or it depends. How did you plant the field, and how straight did you get it? But this looks pretty good, and I'll zoom back in. I can click continue. So the fifth step here is to crop out any extraneous things in the field. Again, I'll zoom out using the browser, and so like there's a road here, and we don't want that kind of stuff in the image. So I just click the four bounding points, and notice this image actually does have ground control points. There's one here, and one here, and one here, and here. So these are just markers in the field that stay there throughout the season. And when I do this cropping, I want to keep them in the picture if I can. So then I can go to the next step. I guess I clicked. Let me just draw it again. And click continue. So this step number 6, it's not really that important. I was experimenting with like thresholding, so like dropping out, say discarding the lowest 25, or discarding pixels that are outside of the distribution of pixels. But the main point here is like that the database will keep the original image. So the original image that we uploaded, and it will also have like a thresholded image, but often, I mean, I've mainly been just using the original image that was uploaded, not the thresholded image. And so there's nothing to change here really. In the future, this might just go away, but I can just click continue. And this step number 7, this is the most important step. It's where we actually draw the polygons. And so there's this templating tool form up at the top. We say how many rows and how many columns we want to template. So I'll say, so remember the field experiment we uploaded had 20 plots. So I'll say 5 rows and 4 columns, or 4 rows and 5 columns. And then there's these 4 buttons here for clicking the corners of the area of interest. To that the area of interest where these 4 rows and 5 columns will be drawn in. So I'll start with the top left corner. So I click this. Tells me to now click the top left corner of the image. So I scroll down and I click the top left corner of the area of interest. So say here, my field experiment it's not concerned with the border rows or borders. So that's why I clicked here, because the border row isn't part of the field experiment. So I clicked there. And then I do the same thing for the top right corner of this area of interest. So each of these is a plot. And so we have 1, 2, 3, 4, 5. So I click the top right point of interest and click the bottom left corner. So we have 1, 2, these are the rows. So 1, 2, 3, 4. And finally, the bottom right of the area of interest. Something like that. And then once I've clicked these 4, I can draw the template, and it'll apply that there. So in this case, I'm going to zoom out a little bit. In this case, it's actually more complicated because we have these big alleyways between the rows, and these alleyways, we don't want them to be part of the plot, and so this has a little bit more functionality to account for that. So first, I'm going to click this red button to clear the image, so kind of start over. But what I'm going to do instead is focus on just this top row first. And so what that means is I'll change the bottom left corner and the bottom right corner that I had defined earlier. So say the bottom left corner is here, and the bottom right corner is here. And then I'll click this button to redraw that. I'll clear this again. So we're just focusing on the first row. So 1 row, 5 columns. I draw that. And then this has you can copy paste that. You can copy paste that template. So I click on the top left corner where I want to apply the same template. So I can do this, copy paste that uh, for these different rows. Now, so I mean, so there's some functionality here. It can probably be more user friendly, but in essence, you get your plot polygons, and you notice they're numbered 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So now the challenge is to map these generated polygon numbers to the field experiment. And so remember, if I scroll all the way down here, on the bottom here, it actually shows you the field experiment that we uploaded before. And so you have your plot numbers and your block numbers, and so how this one way. So there's two options here, because you can either manually assign the plot numbers to these generated plot polygon numbers. So, for instance, like if the polygon number 0 is plot number 1, so whatever you had in your field experiment, so you would do that mapping between plot numbers and plot polygon numbers. But the better way is to try to auto-assign, like have the system do it for you. So if we can try to use this tool, and if the first plot, like plot number 1, is in the top left, and currently it has to be either in the top left or the top right. And the second plot follows, going in the right. And the orientation of the plots. So if it was serpentine or not serpentine, you can select that here. So I'll say serpentine, and then I click generate assignments. So this doesn't save; it will generate the assignments, and then we can scroll back up here, and we'll see. This is kind of a confirmation, like this one here is plot number 1, plot 2, 3, 4, 5, and then it goes serpentine, so 6, 7, 8, 9, 10, and so on up to plot 20 here. So it's kind of a confirmation that your plot polygons are matching to the field experiment. And so if it looks good, you can finish, and so I'll click finish. And here it just says kind of what I've said before. It'll apply that same rotation, cropping, and plot templating to all the other bands. And so there's nothing to select here. It's just showing you it's going to apply it to all the other images. And it'll apply. Currently, these are the indices that I'm looking at. So it'll calculate NDVI, NDRE, and a couple other indices. So I'll go to the next step. And this is the final step. There's nothing to select here. It's saying that it'll calculate so what we call zonal statistics for each plot. So these are like things like non-zero pixel count. But the most important one, or the one that I'm really looking at, or have been looking at, is the mean pixel value of a plot. But yeah, these are the phenotypes that are being extracted, and here it shows you that this imaging event was 6 days after planting. So yeah, and I can click finish, and it tells you that it's going to take a little bit of time to complete, and can click finish. And so it does take some time to do the processing, like maybe 5-10 minutes. So there's this indicator that it'll go away once it's done processing those images. But we'll have to wait.
You are very clear, Nick.
Yeah.
Very great workshop.
Oh, thanks.
Yeah.
I really like it because it's kind of similar to the work that I have been doing, but with an interface. That's awesome.
Thanks. Yeah. No. Yeah. I really liked your workshop too.
Thank you.
Yeah.
Oh, go ahead, Anna. I also have some questions here, actually.
If you want to go ahead, mine, I don't know if they go ahead.
Actually, one question that I receive a lot is about the shapefile. And many people ask about, for example, what's happened when you have curves in the field that's not straight. Because right now what I'm doing, my fields is straight. So to me, the platform that I have been working, this platform works pretty well. But when you start having plots in curve shapes, it started being harder. How you guys thinking to resolve this problem, or this platform can bring, import shape files from different softwares, for example, QGIS,
Yeah. So yeah, but are the plots themselves curved or rectangular?
Curves, yeah. They sometimes, that's a really good question. Another good question too. That I also received. In this case, you show that suggestion, for example, when it's not like when the block's not straight, right? So you can copy and paste, and you resolve when the field's not straight. But imagine trees or forestry is the word, forestry.
Yeah.
When you have different shapes to make the shape files. The plot has different shapes.
Yeah, it's a good point. Currently, like, yeah, it can only do rectangles, but yeah, and so one thing I do want to add is, like, so that you can export that template as a shapefile. but I haven't done that yet. One thing it can do, like, so if you click, if the plot is if it's kind of skewing, like if it's skewing in one direction, like if you click on, say, like you click on a rectangle that looks like this, it will draw the plots like in a staggered way.
Oh, okay, interesting.
But it's like a linear stagger. It's not curved.
I see.
We have two questions actually. Do you want to answer them now, or do you want to take them later?
Let me see if this is finished and. Okay, yeah, I can answer them now.
Okay. So, hi Nick, thank you. What kind of API interfaces RESTful exist with this system? How customizable is the interface? Do you see the question also on the screen?
No.
But yeah, I mean, if you want, I can read it again.
Okay, no. Yeah, thanks. It uses, like, the interface is completely like JavaScript, and so it makes like RESTful calls to the database. But so I mean, it does use RESTful. It uses an API that's like it's not standard. It's just whatever I needed. But I think the idea is to move that to the breeding API, and so that those calls are actually standard. But currently, it's just yeah.
Okay. Yeah, he's also asking, and have you thought about integrating into other cloud services like Cyverse for data access? I guess Docker helps with executing on Cyverse.
Yeah, that's the good thing with Docker, is that the only thing you need to install is Docker. And I haven't used Cyverse, but I imagine you can launch a Docker. You can deploy a Docker thing, but I haven't used it.
Okay, yeah, and there is another one. Is how about fitting different field design for taking into account minimizing the error?
Yeah, so it's a little bit of trial and error, like with the interface, like kind of, clicking it slightly in different places. The nice thing though is once you have it defined once, and that's something I hope I can show, is like you can then use it on other imaging events. So that kind of minimizes the error. At least it's a little bit more repeatable, but it is kind of trial and error getting the plot template to match up.
And there is another one. Do you want to keep going with the question, or do you want to go back to the?
Let's see if finally. Okay, yeah, it's done with the images, so maybe you can.
Yeah, so maybe you can finish, like, I think it's the last part, right? And then we ask question. What do you think?
Okay, sure.
Okay.
So yeah, it's done processing the images, and now it's processing the phenotypes. But so so there's a lot of information here. You can click this, and it gives you a summary of the types of images that, like, so we had 20, there's 20 plots in our field. So we have 20 near infrared images, 20 green images, and it does some combinations of the images, like RGB. And if you scroll down, each of these sections gives you kind of the full, kind of the full view. So if I expand the near infrared, this near infrared section, I can see all of the images that were created for this imaging event. So, like, we have the original that we uploaded, and then we have the the rotated image, and then we have the cropped image, and then we have, like, the individual plot polygon images, and this is all, like, linked up, so like, each image has its own page, and then like, this image is linked to the plot page, and because in the database everything is kind of connected, and so, like, from the plot page you can you could see all the images, like, this plot has 17 different, or yeah, so anyway, maybe that's confusing, but everything is kind of linked up, but this dashboard shows you the information. I'm just going to refresh the page, go back to manage drone imagery, and so if I open this up again, and okay, now it's done completely, and so I want to save ground control points, and so I click here, this gray button, save ground control points for this imaging event. So I'm going to zoom out on the browser, and here we just click on the center of the ground control point, and so click there. We give it a name. So say this is the northwest corner, and optionally I can give latitude and longitude if I had it. And then I click save, and it'll draw it there. And I do the same thing for the northeast corner. And I'm going to zoom out, and then I'll do the same for this is the southwest corner, and well, this is kind of strange, but currently we're looking at the blue image. You can cycle through the different, let me just see the near infrared image. Okay, and then I'll draw so I still need to get this north or southeast corner. Okay. So there I've defined the ground control points for this field. And so if I go back to manage drone imagery, and so let me say I want to, I'll upload another event, another imaging event. Go to next step, select the field trial. Here's like the, it'll show the previous events in this table, and I'll create a new one. Say October 14th, and it was a drone MicaSense 5 bands. Used the blue batteries, and it was flown at 25 meters, and it occurred at October 14th. Okay. And again, I'm uploading orthomosaics, 5 of them, and I'll just select those images. I'll just select the same, because I only have this as an example for this demo. So I'll just use the same images again. But of course, it would be different images for a different time that you flew. And okay. So now we have 2 of them here, and this is the new one. So we have to run the standard process on it. So I click the blue button and go to the next step. And I still have to select the band that I want to take through the process. Okay, but now on this step, I can say that I do have ground control points defined. So I say yes, and then here select the imaging event to use as a template. So I use the October 7 one that we just did, and so I have to click on the ground control points in the new image. So this is the image, this is the new imaging event, and I click on the click on the ground control points in the new image. This is the northwest point, and this is the northeast point, and this is the southwest, and the southeast. And so even if the image was like rotated, or like if it was scaled a little bit differently, this is supposed to work. It may not always work, but so once you've clicked the ground control points, you click this blue button, draw computed polygons, and you give it a few seconds to come up with the the rotation and stuff, and then it'll draw what it came up with, and if this looks good, then you can confirm it and save it. So in this case, like it looks pretty much the same as what we defined for the first one. And so confirm and save, and tells you it'll take some time to process, but that's a much faster or much easier like process. So again, like in a couple minutes, that indicator will come back like that this event is processing, and so just to give it some time to do that. So I guess maybe while that's happening, I can show. So like we have phenotypes extracted for this event, but I haven't really shown you anything. So what we can do is we can go to this field trial, go to the detail page of this field trial, and we'll be able to see the phenotypes that were extracted. So if I go search field trials, and you'll get a search table for field trials, and you click on the trial you're interested in, takes you to the detail page we saw earlier, and so we can open up this section, the phenotype summary stats, and it'll give the just show you what phenotypes are saved, and so like I don't know if I look at the mean pixel value, or I don't know, if I look at NDVI, so the trait name is kind of complicated, but I don't know if you can see that well, but the trait is kind of complicated because it's a combination of a few things. It's the value that's actually like so in this case it was the harmonic mean, or in this case it was just the regular mean, and then there's a pipe separator, and then you have some information about the image so some information about like where did that mean pixel value come from. So in this case, it was a NDVI image. And then finally, there's the day. So this was 6 days after planting. Because what's going to happen here is you'll have like day 6 or day 20 or day 100, and so you can separate. You can do like a time series to see like to separate those repeated measurements. So there's this table that has all of that, and I don't know, you can plot. There's a histogram here, just to see the histogram of the phenotypes that were. So in this case, it's the mean pixel value for the near infrared image at day 6, and you get a plot of it. So that's handy just to so that's how the phenotypes are stored. And of course you can just download an Excel file of this data. Just click download and just give me everything. So I'll just submit, and you get a Excel file. This is comma separated. So you open it up in Excel, and you'll get a big data file with like the field experiment information, the germplasm information, and at the end here, like all the phenotypes are listed at the end of this file here. So you can take that and move forward. So I think with that, and I did have more to show, but I don't think I have time to show.
Yeah, I don't know. We are pretty tight. What do you think, Felipe?
I guess.
How long is that other part?
Yeah, I think I'd. I mean, I don't.
Yeah, we do also can schedule another workshop.
Yeah.
What's gonna be great. And first of all, man, congratulations. You're doing a really great job. It's pretty impressive. Yeah, thank you for putting all this energy to make this tool. It's pretty needing. Yeah, thank you.
There are 2 questions, but I have 1 question. We'll start with the audience question because
let's invite Kelly for be part of this final part. Okay, Kelly. Hey.
Hey, great presentation, Nick. Thanks for that.
So it's still Andrew. Is ImageBreed active development for these under the breed base code set? If so, where is the active development being done?
Yeah. So. Well, yeah, it's in active development, and it's done in Lucas's lab mainly, and the main code base is here. So this contains all the uh, all the web interface, database code, and yeah. And here you can also, like, I mean, GitHub is, I don't know if you've used GitHub, but it's very good for management. Like, you can create tickets for bugs, and you can, like, track all kinds of stuff.
There is another one. Sorry, I joined a little late. Does it consider trait related to drought tolerance as well? Thank you.
So, sorry, can you repeat that?
Sorry, I joined a little late. Does it consider traits related to drought tolerance as well?
Yeah. So traits. Traits can be any number of things. Like, for instance, I go to search traits, because the database is actually, it's designed so you can upload an Excel file of trait data that you have collected, manually or otherwise. And so the way to do that is to have an Excel file that that uses traits that are in the database. So, like, I don't know if we have anyway, yeah. So these traits can be added, and then you can upload data for those traits.
Yeah, I mean, I would add that the database itself is quite flexible to accommodate a large variety of traits. I mean, when you set it up, you have to define those traits and various ontologies associated with them. As far as the actual derivation of phenotypes from the images, we've started with vegetation indices because that's what has been up until now the focus of our lab. But again, BreedBase is open source. It's a collaborative community. In addition to the BreedBase team, there's some funding for some developers in my lab to work in this area as well. So I would imagine that this would continue to expand moving forward. But in terms of images, correct me if I'm wrong, Nick, but it's mostly vegetation indices at this point, right?
Yeah. I mean, it'd be great, like, you could if it could do stand count and those kinds of traits, but currently it's just vegetation indices.
And just a note on the APIs as well, that there is an active effort to make this make the interface operate off of BRAPI defined RESTful APIs. So those would be very standardized APIs. The BRAPI right now is not built to handle a lot of the use cases specific to this. So that will be an ongoing effort, but it is definitely the direction that we're moving, and that would enable not just the native interfaces, but it also would enable people to build custom interfaces on top of the database to do things maybe that aren't currently available in the native web-based interface.
Cool, great. Yeah, thank you guys.
Yeah, my only question is about the threshold part. When you so you say that you are going to remove that part, and you are thinking, I don't know. I think I was wondering if that can be important when you don't have very defined rate. Like, sometimes you have in the same field, maybe not, when you have a big breeding program, you have so many very defined plots, but maybe when the breeding is small, you can also close like different species, or also like a flag or any other things that can be a noise for the threshold part can be useful for that, or do you think you can just change the field chart map?
Yeah, that's a good point. I mean, I think that was the idea. Like, that's why I wanted to have the thresholding, because especially sometimes like weeds, or it just becomes very hard to even look at the image, or like to define the plots. But actually, yeah, I mean, I've looked at maize and alfalfa. That's what I'm working on now. And for those, it hasn't been an issue, but yeah, it's a good point.
Yeah. I don't know. There is another question. Do you guys want to take it? Or?
Yeah, I mean, I could take that one real quick. So the questions about factors that influence image collection in general. So I mean, the pipeline is set up to process in a very defined way the images that are fed in. There's some I know there's been some work to look at different types of QC filters that you can apply. But in general, if you feed it a low quality image, you're probably not going to get a very useful phenotype out of it. So, in terms of, if there's cloud cover and shadows across the fields, you may be able to do some spatial corrections to try and deal with that. But even in the runs we've done, we find that some of the flights, flight campaigns, just, when we process the images, we just have, very low heritabilities. We're not, capturing much signal relative to noise. And so it's the pipeline itself isn't going to be able to correct, a lot of those problems.
So you will need some pre-processing.
Well, I mean, yeah, so some pre-processing. There's obviously limits to what pre-processing can do. If the image itself is just not of a quality to allow you to really derive meaningful phenotypes, there's not a lot you can do about that. But.
Yeah, just to add on, like, I mean, the orthomosaic generation, like the software you use for that, it does do a lot of calibration or kind of pre-processing, and so that we're using Pix4D, but I think OpenDroneMap can also work. But that does a lot of pre-processing, and it tends to remove a lot of, or it's hard to say, but it does a good job from what I've seen.
Yeah, we had also the workshop on OpenDroneMap, and yeah, the girl was showing how to kind of do that.
All right, guys. Yeah, we are in time. So thank you so much again for being here, for sharing your work. It's keep doing this and keep us going, and let me know when you have new tools inside yours, and then we can schedule another workshop for you guys come here with another example too. Thank you so much.
Cool. Thank you.
Thanks. It was great. Thanks for having us. And, yep. And anyone that has questions, feel free to reach out to Nick or myself individually. So.
Yeah. You guys have, I think, below the video, there is also the GitHub page where you guys can contact them.
Yes.
Yep.
In the descriptions. Okay.
Thank you.
Bye-bye, guys.
Okay, thanks.
So times to conclude this workshop and advertise our next workshop, the last one actually.
Yeah, how do you feel about that?
Yeah.
Time passes really fast, right?
Yeah, it's very good. I really enjoy it. And I think I learned a lot because, we started this because we wanted to learn also. So I learned a lot and it was very great for me. And I hope the guys that have been following, they have learned a lot too.
Yeah, awesome.
So
yeah, go ahead.
No, go ahead.
Our next workshop is gonna be next Friday. It's gonna be our 10th workshop in the series, and then we are gonna have a break.
Mm-hmm.
And our next workshop is Larry York.
Yeah, I think I think has the again connection issue. I don't know. So it's
Okay,
Larry York, and he's going to present Rizzo Vision Explorer, which is a whole application for analyzing root scan or root images. So here there is the flyer. So as usual, if you have already registered for this workshop series, you don't need to register again because we send information every Thursday. But of course, if you think there are people interested in, just share the registration link that you find here. And what else? And I think next workshop we are going to talk also about some possibilities for our events in 2021. And yes, so thanks for joining us today and see you next Friday.
Bye, guys. See you.
Bye-bye.